it's really a privilege and a pleasure for me to be introducing and chairing this session, introducing Professor Paulus Gerdes, and to be talking about maths and maths education for a change. So I'll just go straight into it. We are hoping to manage the session a little bit differently in that Professor Gerdes will do his presentation, and then I will respond with a few remarks, and then open for discussion and try to construct it more as a conversation. So we would like to have less sort of questions and more of an interaction among yourselves and with us together. So it's really a privilege and an honor for me to welcome Professor Paulus Gerdes, who is a full professor of mathematics. He served as a dean of the faculties of education and mathematics of the Eduardo Mondlane University in Mozambique. He has also been Vice-Chancellor of the Pedagogic University. He has served as Senior Advisor to the Minister of Education and as President of the Commission to establish the Lurio University in Nampula in Mozambique. He directs the Ethnomathematics Research Center in Maputo. He served as Secretary of the Southern African Mathematical Sciences Association and as President of the International Association for Science and Cultural Diversity. He chairs the African Mathematical Union Commission on the History of Mathematics in Africa and the International Study Group for Ethnomathematics, which incidentally is going to host its next conference in Mozambique next year. He has been a visiting professor and invited speaker at conferences and universities all over the world, too numerous to mention here. He is also a fellow of the International Academy for the History of Science and fellow and current vice president of the African Academy of Sciences. In 2012, he received the highest distinction, Prize for Excellence in Higher Education, Research and Teaching on the occasion of the commemoration of 50 years of higher education in Mozambique. Professor Gerdes has authored almost 60 books, some of which he will introduce you to today, including some award-winning ones and over 100 papers in peer-reviewed journals. Please join me in welcoming Professor Gerdes.
Good morning, colleagues. First of all, I would like to thank you, the organizers, Deputy Vice-Chancellor Nuko Vital, and Ruby, for the invitation to come to this conference. And I was initially invited to take part in a panel about re-envisioning mathematics curricula and higher education, together with Professor Christian Keitel and Professor Andila Miji. And unfortunately, both couldn't come. So we have to adapt ourselves. But the two other colleagues are curriculum experts. And I should like to underline, underscore, I'm not a curriculum expert. I'm interested in curriculum, but it's not my particular area of research. But we'll try to raise some questions, pose some questions about curricula, in particular mathematics curricula, in higher education in Africa. I've been working, like was said, for many years on the history of mathematics in Africa, not only in Mozambique, but on a continental level, through our commission of the African Mathematical Union, its commission on the history of mathematics in Africa. The acronym is AMUGMA, and if you look for this, you can find a lot of information on the web, because I have a website. And newsletters have been published since 1986 in English, French, and Arabic. As one of the results of the work of our commission, together with my colleague Ahmed Jabbar from Algeria, we published various versions of an annotated bibliography on mathematics in African history and cultures, with more than 2,000 references about research done about mathematics in African history and cultures. So to say today, in 2013, we don't have any bibliography, it's not true. maybe 30 years ago it was true, today not. A lot has been done in the last 20, 30 years. And it's changing completely the picture on the history of mathematics in Africa. We published also 2 years ago a book on Agmugma, 25 years, history of mathematics in Africa. As you can see in the number of pages, a lot of information is known about the history of mathematics in Africa today. So I should like to present today some questions for reflection and, if possible, to tell some stories related to curriculum development in mathematics in higher education. But first I would like to pose a very general question for reflection that would always be good, not only in the context of curriculum development, but also when we are thinking and talking about mathematics, education also, to take into account. Who does mathematics? Who invents mathematics? What is mathematical thinking? And very importantly, who or which culture or which cultures define what is mathematics? And what means the interaction between various cultures about the development and process of developing mathematical ideas. Before going to this conference, I went to look to the website of the University of KwaZulu-Natal and want to know what is the mathematics curriculum at this university, both at the undergraduate level and the postgraduate level. Unfortunately, the postgraduate courses are not on the website, so I could not find information. But I looked to the undergraduate courses. And I saw a list of mathematical courses, and for each course, a list of mathematical topics. And what I remarked was that this list is not very different from maybe other universities in South Africa, from other universities in Africa. But when I looked at the list, and I remember when I was studying myself about 45 years ago in Europe, the list was almost the same. So we ask, why does it happen? Yes, sure. Close to the mic, but afterwards I want to walk, so it will be difficult to.
The roving mic.
Yes, that would be.
Mohammed? Yeah.
I'm not used to stay at the same place. I'm a walking person. You hear something? Okay. I was surprised, but I know this is happening, that curricula, or mathematics curricula, in many parts of the world look almost the same. You may ask, 2013, Durban, South Africa, 1970, in a certain European country, the same topics, more or less, in the same presentation. Why does it happen? So we ask, how are these topics presented at this university and other universities? Are they presented culture-free? Are they presented as being above culture? Are they presented gender-free? Are they presented without history? Let me ask, a person outside the university looking to its website and maybe wants to study something of mathematics at this university, what is the image that is given, that is presented? Mathematics seems culture-free, only list of topics. It seems to be above culture, it seems to be gender-free and without history. Let me just give you an example. Not all of you are in mathematics, but some are in engineering and other fields. This numerical triangle is studied also at this university and in most universities in the world, and used in combinatorics. 1 + 1 gives 2, 1 + 2 gives 3, etc. How is this numerical triangle known or called? I think most of you are using it, or maybe using it in probability theory, etc. How is this triangle called? That has a particular name. is normally known as triangle of Pascal. And the numbers are also known in the binomial of Newton. Pascal, Newton, European names. Pascal, a French philosopher and mathematician in the 17th century. All over the world, let's say maybe outside China, in the rest of the world, this triangle is called nominally the triangle of Pascal. Remember, Pascal, 17th century. Now let us leave Pascal in France and let's return to the African continent. Here you see a manuscript, or page of a manuscript, of Ibn Munsing, an African mathematician. And look, he's writing in Arabic, but he's not Arab, he's an African. He's writing 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 4, 10, 10, 4, 1, etc. The same triangle, in a different position. The numbers are written almost in the notation we are using today. But when was it written? In fact, it's page 328 of a manuscript. It was written in the 13th century, 4 centuries before Pascal, an African mathematician. In his book, formulas which are known and maybe present also at the University of KwaZulu-Natal as the formulas of Cardano, Tartaglia, Frenet, etc. All these formulas of the 17th, 18th century are appearing in this manuscript of the 13th century by an African mathematician. Sometimes it's said applied mathematics starts with applications in physics, natural sciences. This book is a book about mathematical linguistics in the 13th century and not in the 21st century. Mathematical linguistics. Ibn Munsing was paid for to calculate how many words of certain lengths you can form in Arabic, taking into account the rules of forming words in the Arabic language. And it was a very difficult problem. So just like a mathematician in the 21st century, what did he do? He tried to simplify the problem, and by simplifying the problem, solving simple problems, and introducing all basic formulas of combinatorics. That is taught also at the University of KwaZulu-Natal. But who at the University of KwaZulu-Natal is learning? It was first discovered in the 13th century. Oh, I'm jumping. Oh. It's very dangerous to work with technology. Who could imagine that it was done in the 13th century in north of Africa? 20 years ago, nobody knew this. The manuscripts of Ibn Munsing have been discovered about 18, 19 years ago. And many manuscripts have been discovered of the Middle Ages in the last 20 years, have been translated and analyzed, and give a completely different picture of the contribution, in particular of the north of Africa, to the development of world history. So triangle of Pascal, formulas of Cardano, etc., European names, but a Eurocentric vision of mathematics. In fact, this mathematics was developed in Africa. I think most of us, I don't know if there are exceptions in this room, are using cell phones. Many of us may use calculators. What do cell phones and calculators have to do with the history of mathematics, and particularly with the history of mathematics in Africa? If you take your cell phone, you see symbols. And may ask, when were symbols introduced in mathematics? All of you on the calculator, we see symbols like plus, equal, square root, or we can see symbols like fractions, etc., notations. For the first time in history, notations, abbreviations for the arithmetical operations were introduced for the first time in world history in Africa, in the 12th century, in the northwest of Africa, in the Maghreb. I will show you a manuscript. Here you see a page of a book written in Arabic in the 12th century. Maybe some of you know Arabic. I don't know. But not knowing Arabic, we can see some things. What do you see over here? 1 over 10. More or less 1 over 9, 1 over 4. See, notation of fractions, also taught in South Africa today in primary schools. 12th century, and this is a continuous fraction, these are normal fractions. This fraction notation and those symbols for addition, multiplication, subtraction, etc., invented in the 12th century for the first time. And this notation is still used and taught everywhere in the world today. We may ask, who was the author? And maybe nobody, almost nobody in the room knows the name, but I hope you will never forget the name. Who was the author? As far as we know at this moment, and these manuscripts have been discovered about 15 years ago, as far as we know, the oldest manuscripts in which these symbols are appearing, and which also the notation of fractions is appearing, was written by a mathematician who was assassinated in 1204, Ibn al-Yasamin. A mathematician, poet, professor, and maybe also say a very famous mathematics educator. He was, like I said, was killed in 1204. Ibn al-Yasamin. If you look at the name, you may think it was an Arab, because the name is in Arabic. The name, if you translate it into English, Ibn is son of the jasmine flower. And we ask, why would a male being called the son of a flower? Who would be that flower? The father or the mother? It's the mother. Then we ask, why would somebody be called the son of his mother and not the son of his father in this cultural context? And the answer is very interesting. His mother was a black slave from the south of the Sahara, who was imported to northwest of Africa. And Ibn al-Yasamin is described in the 12th century as, I'm translating literally as it's said in Arabic, as black as his mother. It was a very exceptional figure. And in terms of mathematics, a revolutionary. He introduced symbols, introduced new notations, and as a mathematics educator, introduced new mathematical teaching methods. I said before, he was a poet, not only in general, but he used poetry in mathematics education. In the context of shortage of books of text for students, he thought it would be good to teach at higher educational level the theorems about algebra in form of poems. And those mathematical poems have been used during more or less 4 centuries in the north of Africa, not only in the Maghreb, in the whole north of Africa, to teach at university level the basics of mathematics. You may ask, who nowadays, as a mathematics educator, can hope that his or her methods will be used during 4 centuries? So he was very successful as a mathematics educator. But of course you can imagine, son of a slave, and I should say, in agreement with the law at that time, when a slave had a child and the father was a free man, the slave was freed. So Ibn al-Yasamin grew up as a free man, studied in the south of Spain, in Sevilla, came back to the north of Africa, and then advanced with development of theories. Because he was such an exceptional person, of course, it could also create problems in his life. And that's one of the reasons why he was assassinated in 1204. So it's very important to know you're using your calculator, your cell phone, and some of the important ideas were developed by an African black mathematician. And it's very important now we are speaking about Heritage Day this week, how to value the African heritage in mathematics and in mathematics education at all levels. Returning to the cell phone or the calculator, how is multiplication being done? The binary number system is used, but the way of multiplying is the same way as multiplying was done in ancient Egypt, by a repeating doubling method. And this doubling method of multiplication is very well spread all over the African continent as a basic method for mental calculations. So the heritage of Africa in cell phones, in calculators, is very strong. So may I ask the place of history, culture and gender when we are thinking about curriculum development at any level, in particular at higher education level and in the case of South Africa. May I ask, and we are still in the week of celebrating Heritage Day, what is the place of South Africa in the history of mathematics, in particular in the world history of mathematics? What are the oldest oranges known in the world about mathematics? About 70 to 80,000 years ago in the Western Cape, or Eastern Cape, in the Blombos cave in the south of South Africa. Here you see a photograph of the cave on the outside, here from the inside looking to the ocean. This area east of Cape Town. And objects have been found like shells and stones with very interesting structures. Here you see parallel lines and some rectangles. You see triangles, more or less of the same size. You see some rhombi also. These are the oldest geometrical designs known in world history. Nowhere else in the world, within 30,000 years of this period, such type of designs can be found. It's very important to underline this is found in South Africa, and nowhere else in the world. If you go to KwaZulu-Natal, about 33,000 years ago, to the Libombo Mountains, near the border with Mozambique and Swaziland, we can go to a particular cave, you're looking out over the Lowveld, where has been found a counting rod dating back about 33,000 years. It's the oldest counting rod known in world history. Once again, in South Africa, and more than that, in KwaZulu-Natal. When we present the program or curriculum of mathematics, whatever the topics are, we have to relate it to cultures, to where they have been developed, to motivate students, and to make students proud of their heritage, including mathematical heritage. Not only of today's cultures, but also of the long and very long history of the continent, and in particular also of South Africa. May I put some further questions for reflection? Ruby and Renuka published a book about alternative access to higher education, and the subtitle, Underprepared Students or Underprepared Institutions or Institution. I would like to add an extra expression, like we were discussing yesterday, underprepared curriculum. And in particular, I want to make some reflections, present some reflections, and ask some questions about curriculum development and student motivation, student engagement. And in that context, I would like to tell you shortly 2 small stories from my personal experience with curriculum development some decades ago. First of all, first story is immediately after independence of Mozambique. Mozambique became independent after the liberation struggle, independent in 1975. And in the colonial period, never any mathematics educator, any mathematics teacher had been educated in the country. So you can imagine a big country without mathematics teachers. So the first teacher education program started at the university, today's Eduardo Mondlane University, in 1977. Where did they get the students from? Now we got some students. We got 21 students to start with this first teacher education program. But none of them wanted to become a mathematics teacher. They went to the program because they were sent to the program. They accepted to be sent to the program because they were enthusiastic, independence, revolution. All tasks were accepted, even to become a mathematics teacher. So we received 21 students. Nobody liked mathematics. I have to correct a little bit. One student liked mathematics, but 20 did not like mathematics. Only one wanted to become a teacher, but not a mathematics teacher. So no one wanted to become a mathematics teacher. And like I said, 20 of them said they didn't like mathematics. Our team of lecturers came from different countries in Europe, from America, from the south of America, from Burundi. So nobody of us knew what to do. We had 9 months to transform those 21 students into mathematics teachers. 9 months. So what type of curriculum for 9 months to train, to educate the first mathematics teachers of the country? And even knowing that only one liked mathematics, more or less, and 20 did not like mathematics. How to work with those students? So first of all, we did interviews individually and collectively with all these students and want to know why they didn't like mathematics, to see how we could write a curriculum or prepare a curriculum to answer their worries, their math, anxiety, etc. And the first reason the student said, mathematics is violent. For us, as lecturers coming from the outside at that time, we couldn't imagine what is the relationship between mathematics and violence. But then the stories were coming from the students. When a pupil didn't know his tables or her tables, he or she would be punished with a rod. The relationship between violence and mathematics education. More than that, the way to block African students from going from the so-called black schools, indigenous schools, to official schools, the way to block them was mathematics and exams. So very few pupils could continue to study. So the association between violence and colonialism was very strongly related to mathematics. The second argument why they said they didn't like mathematics was mathematics is useless. The country is independent. Let's develop the country. Let's become physicians, economists, lawyers. Why to become a mathematics teacher? Why to become a teacher of something useless? So the opinion that had been created in them during the colonial education was mathematics is useless. And then the third argument, very important, he said, mathematics seems very strange. It seems alien. It seems without any roots in our African society. So if it is necessary for the country, if it might still be useful for something, why don't buy it? I can buy an aeroplane, or I can buy a car. Why don't buy mathematics? It has nothing to do with us. You can import it from the outside. So our team of lecturers was discussing what to do. And they did also some testing, and we saw in maybe the South African language that the students were very underprepared mathematically. So what to do in 9 months with these students. And one thing was decided by our team, in discussion with the students, engagement with the students, to introduce a subject called Applications of Mathematics in the Daily Lives of the Populations. I was trained as a pure mathematician, and I was given the task to teach applications of mathematics in the daily lives of the populations. It was an extremely interesting experience for all of us, both students and for myself. On the first day, we went to visit a brewery in the center of Maputo. And the students had tasked to look around in the brewery, producing beer, and see if something is done with mathematics. And they were very shocked. They came out and came back to the class completely shocked. Why? They saw that the workers in the factory, in the brewery, were working with negative numbers. All of the students thought negative numbers are something of the colonial period, just to entertain students, to make life more complicated, etc. Never had any one of them imagined that negative numbers could be used for something. And then suddenly see workers who never went to school, work in a brewery, and work with negative numbers. They were completely shocked. After the first 3 months, we had discussion, evaluation of the first part of the 9 months program, and the students said, instead of having 4 hours a week of application of mathematics in daily life of populations, we want to have 8 hours. So it was a compromise, it would become 6 hours a week. After the second trimester, they knew already how to negotiate. He said, we want to have 20 hours a week of application of mathematics in daily life. It became 10, more or less. Now let's look back, 2013, to those 21 students. One left the country during the year, so we remained with 20. So we ask, where are those students now? Almost all of them are working in mathematics education. 5 minutes remaining, I'm just starting. Okay. Almost all of them are working in mathematics education. Some have done a doctorate in mathematics education. One has been Dean of Faculty of Science. One has been National Director for secondary schools. One is Vice Chancellor of the university at this moment. All contained in mathematics education and have done a very successful career and have been very influential in creating and developing mathematical education and education in general in the country. Interestingly, one of the booklets produced in the context of that program of application of mathematics in daily life populations has been used in 89-90 by the NEC Mars Commission in South Africa to show so some of the application of mathematics in daily life populations. The most difficult part was how to advance with the fact that students were feeling mathematics was alien, was strange to them. And that third argument was the reason why research in Mozambique started about mathematics and culture. Now let me give you a second story. We are jumping from 1977 to 1993. In our program at our university, we had an undergraduate course called Geometry and Symmetry. It was an optional course. I don't have time to elaborate on that. At our universities, we have often, besides official courses, the students can opt for certain courses, and then we have also extra voluntary courses that students can take in the weekends if they like. But it was an optional course. And the question was, for me as lecturer of that course, which topic, which theme to include in that course on geometry and symmetry. But the way to go forward was not, I will decide. I'm the professor, I will decide. No, let's discuss with the students what type of topics they would like to study. And for what reason. So we spent about 2 weeks about discussing what to do with this course. It was a 2-semester course. And what were the themes that students would like to study. And they came up with very interesting things. And which themes, I would like to propose as the lecturer of the course. Now, after heard and analyzed the proposals of the students, one of the proposals I made myself was to use Tonga basketry as one of the themes for this course on geometry and symmetry. Tonga is a population group in the southeast of Mozambique, about 600 kilometers northeast of Maputo. And among the Tonga, women are producing very beautiful baskets. And you can see this many types of designs. And for example, all these designs have different types of symmetries. So I thought it might be interesting to study this topic within the course of geometry and symmetry. And there were about 14, 15 students in our optional course. And the first reaction was, no, we don't want this topic. And you have to imagine the cultural context in Mozambique and at higher education, and in particular in that period. When I say 15 students, it means more or less 13, 14 different mother tongues. So we have to speak in Portuguese with each other, but almost all students speak different languages. I come from different parts of the country. It's a very multilinguistic, multi-ethnic, multicultural environment. So when we were discussing, the students say, now, that's a rural topic. We want something modern, something of modernity, not something traditional from the rural areas. And in particular, two female students, the other were male students, two female students said, no, we want something from the city, from something for the future, not something from the past. And then suddenly one of the 15 students or 14 students became angry. And he was the only Tonga-speaking student in the class. He was getting the impression the other students did not value his culture. His culture, Tonga culture. But this is female culture. So the male students became angry. He said, no, this should be a topic. And then in the political context of Mozambique, where it's a very strong emphasis from primary school onwards that all culture should be valued in society, in that context, the other students became silent. Okay, he wants to have this topic because he's Tonga in a program. Okay, let's accept it. Accept it for political reasons. Not because they liked it to have as a topic. They said, let's accept it. So I thought this more or less a peerless victory because they accept my proposal now, but in fact they don't like it. Then I asked the student, the Tonga student, what he did know about this basketry and about the weaving and the symmetry. And didn't know anything about it. He had seen the objects, but never thought about what could be the geometry involved. So then we combined the following. As this is a 2-semester course, 1 minute, okay, I have to be very quick. As a 2-semester course, we'll do all the topics during the first semester. We'll do this topic in the second semester, and during the holidays, the student will do field work in his community. And his field work was extremely interesting, because as a man, he went to work with women and try to learn their knowledge. And he came back and he taught this subject to his colleagues in the second part. And then something very interesting was happening. We were formulating many new mathematical problems inspired by these designs. And for example, to calculate how many designs of a certain dimension can exist. And then trying to solve that problem during several weeks, one student was advancing much more than the others. And there was a female student. It was exactly one of the two female students who said initially, we don't want this old topic. And she became very engaged. And she came to explain to the other students the results she had achieved mathematically. And she became very proud of herself. And then in the end evaluation she said, this experience with this particular topic changed completely her outlook on mathematics. She felt for the first time in her life she could do mathematics herself and not just reproduce mathematical ideas of others. Developing curricula involving and engaging students. These are two big books related to this experience. I have 10 seconds, I suppose. Okay. So, a question I would like to raise is how we can make in one way or another flexible and experimental curriculum. I don't say that the topics which are on the curriculum at University of KwaZulu-Natal are not useful, are not good to achieve their purposes. But you have to see how to engage students in developing also, in my opinion, to develop the programs, the curricula, so that the students are becoming more and more motivated, engaged in this development, and are losing this process if they have their mathematical anxiety, and are seeing that they can produce, and that their cultures all over South Africa have been producing mathematical ideas, and these ideas can be serve as a basis, can be embedded into mathematics education at all levels, and particularly also at the level of universities. How to see the value, how to value the cultural background of all students in the context. And that context also, the importance of combating Eurocentrism, in the history of mathematics. And I gave you some examples. And I had a unique opportunity. Instead of giving a workshop after this lecture, I had to give it yesterday. So yesterday I had the possibility to show some concrete examples of how the history of mathematics and the culture of mathematics can be embedded into teaching mathematics at a university level. Some of my books, translated in English, can give you some picture if you want to have a look afterwards. But maybe some can be said also in discussion. So I have minus 10 seconds, so I'll give...
Thank you, Professor Gerdes, for this fascinating talk. I want to respond in a way that contextualizes this talk within a really growing area. As you've seen, we, in the last 30 to 40 years, from about the late 70s, early 80s to now, there has been an explosion of research showing that all peoples of the world, all cultures, do and have done mathematics. So one of the areas to which Professor Gerdes has contributed enormously with Professor Wiritan D'Ambrosio and others, and now is international conferences are held, the field of ethnomathematics, has really shown and analyzed mathematics in many, many different areas and aspects. So one of the questions this raises for us, and I want to focus on the university curricula, is that where in the mathematics curriculum is the question asked, whose mathematics am I learning and why am I learning it? If I think about my own mathematics undergraduate curriculum, that question was, I never thought of that question, we never posed it. And now that we have the enormous, you've gotten a glimpse of the enormous literature that exists in this area now, there must surely be the question, how does this research now get fused into the curriculum? What is its role and place in undergraduate and postgraduate curricula? I want to broaden the area of work that is focusing on the social and cultural dimensions, but raise it more broadly to say where in the undergraduate or even in postgraduate curriculum are knowledge bases and the next generation of researchers who could participate in extending our knowledge about the history of mathematics, the philosophy of mathematics, the sociology of mathematics, which are really growing areas in the field. Which mathematics students would be encouraged to go in that direction? I returned to mathematics in a way quite late in the master's program when these sorts of topics were presented for the first time. So what I'm raising are the questions of the undergraduate curriculum and where does this kind of critical thinking, this kind of broadening of what mathematics is happen, in addition to the questions that Professor Gerdes is raising. There is, of course, another allied area that has grown of critical maths education, which asks really serious questions around the ethics of the applications of mathematics. So I remember in 1996 at the International Congress of Maths Education, we had a presentation around this issue. And there was just a fascinating statistics given that more than 80% of the world's mathematicians work in military-related research. So it begs the question, because mathematics is used in so many areas that shape decisions in very fundamental and serious ways. where in the curriculum or in research training is the ethics and the social responsibility and political responsibility of the kind of mathematics and the applications of mathematics as it goes forward. So you heard that applications of mathematics are absolutely the foundation of the technology that just populates the world in ways that we could never have imagined even just 10 years ago. So whose responsibility and where is that is some of the questions that as we begin to understand mathematics in this much broader way raises for us for the curriculum. So then it also comes to this question then of the assumption and almost taken for granted that mathematics should determine entry into higher education. We seldom, we have just accepted that if you take at UKZN, and I did an analysis of this, there's very little you can get into the university without mathematics. You can maybe do some programs in humanities and maybe a program or two in law. Otherwise, there's nothing else you can do. Not economics, not any health sciences, not any. And yet, do we really know if mathematics is, or competency in mathematics is really shapes success beyond that? So I'm just raising that as because we have been doing some analyses which are beginning to show, statistically at least, and the statistics colleagues in the statistics school have been doing this research, is showing that when we look at performance in mathematics and performance in university, how students do in mathematics is not a contributing factor at all to how they are performing in university. So quite controversial, quite provocative, but given the role of mathematics in the curriculum and in future life opportunities, how should we shape its place? So I'm going to just pause there, just as part of the broader discussion. So I'm spanning the social, cultural, political, ethical dimensions of mathematics, and I would like us to maybe raise questions about then. Based on what you've heard from Professor Gerdes, and just a few ideas that I'm raising in relation to that in the broader context, to question some of the taken for granted foundations. Right.
We have actually 6 minutes.
Okay.
I want to give full justice to the next speaker. Can we have one round of questions?
Let's do that. Okay. So let's just raise the questions. We don't necessarily need to answer any of them, or feel free to respond to something. There we go.
Thank you. I'm Professor Mwingi from Polytechnic for Namibia, School of Information Technology. I followed the workshop of Professor Gerdes yesterday. Very, very, very insightful. And because one of my interests, okay, don't have much time. Let me go straight to the question, to the contribution. How do we bring the mathematic culture and skills at the right level? Should it be university level, undergraduate, secondary, primary, kindergarten?
Okay.
That is.
Okay, so how do we bring it into the curriculum?
The right level.
Yes.
Not necessarily at the undergraduate.
Sure.
If we want to build really something.
Okay. Some more comments? There's another one there. Go ahead.
I would like to thank Professor for his very insightful comments. I had a chance to have students in teaching practice. And one of the things I asked them was, is Chabalala brave in mathematics? The soccer player of South Africa, we know him quite well. And the response was immediately no. But I had a way of showing them that he's actually applying mathematics when he's kicking a ball. Yes. And I think it's the approach that we lack in our classroom. Yes. I feel very emotional about it because I feel that a lot of my classmates will have made it to the university and beyond if they had teachers who were instructed in knowing that it is your approach to the subject that makes the difference in the way the learner, feel about the subject itself.
Thank you.
Yes. Thank you very much.
There's another comment there.
Maybe just to build on that, I think in the South African context, particularly in the context of teaching mathematics in the rural areas, I don't think that maths should be a criteria for advancing education. I don't think, and the students that I've had contact with, that their ability reflected in their matric results is a reflection of whether or not they are capable.
Okay. Do we have any other comments? One at the back there, Priya.
Thank you. I'm not a mathematician and haven't done anything formally with it since school, but I must say Professor Gerdes' issues apply so powerfully even to English literature and to the teaching of literature. It's the same challenges that we have with curriculum, and I'm quite struck by how valuable the issues that he was raising are for other disciplines and for curriculum development in them and research, further research in them. Thank you.
Thank you. It's a very nice interdisciplinary aspect to it. Are there any other one final comment at the back there? And we'll take the last two there. Yeah.
You may have read a bit of my research about this issue. I did some not hardcore statistical analysis, but a fairly innovative way I found to analyze student performance and its relationship in the sciences. And the variables that I included in my analysis one of them was maths performance at school. And in fact, I found an inverse relationship between maths at school and the performance in the biology module of the Access program, the Science Access program. So there was an inverse relationship between that particular module and no relationship whatsoever with any of the other science modules. Plus, there was no relationship between maths performance at school and their overall ability to proceed into mainstream science. Thanks.
Okay, so I think this is going to be opening a whole other area. But let's take the last comment, and then I'll ask Professor Gerdes to make a few closing remarks.
Thanks, Mike Hart. I just wanted to know, you were training teachers through this method, teacher trainers, were you?
Not only.
They were trained, yeah. But how did that type of stuff that you do then permeate into primary school maths teaching and that sort of thing? That's what I'd be interested to know.
Okay, thank you for your comments. I'm going to ask Professor Gerdes, feel free to respond to or comment further on any of the points that were raised and make your concluding remarks. Rabbi, you robbed us of 5 minutes in the beginning, so you will let Professor Gerdes speak.
I would like to answer the last question, but to do so,
It will take a long time.
I should tell a story, but I should show some photographs, and it will take some time to find the photographs, so it's not possible. But at a talk I gave 2 days ago at the UT, I told a story about to show the long-term influence of this type of work, later on replicating in primary school teacher centers, and then later on, sometimes 10, 15, 20 years later, you see the really effects in primary schools by initiatives taken by teachers teaching in areas where they don't know the mother tongue, because they have themselves another mother tongue, but they know and have learned how to pick up cultural elements in the environment of the students and are taking that as an advantage point, as embedding it in it possibly. And at the level of primary school education in Mozambique, we have a very interesting law. That's the law of 10%. And it means 10% of the curriculum in primary schools can be used by the teachers for local environment. And to see how to explore local environment, family stories, culture story, dances, and also mathematics. How to do that? And in the last 10 years, at the national level, the Ministry of Education has been trying to collect all those interesting experiences and try to disseminate them at the national level to see the interesting initiatives taken. At the secondary school level, higher education level, there's much more external pressure on the curricula. And it's more difficult, let's say the last 15, 20 years, to introduce change of the curriculum. Because change of the curriculum depends a lot on who are the financiers. And the financiers have a lot of influence. And in our case, a large part of the budget of education is financed by foreign countries. So there are a lot of interests involved, and in particular case of mathematics, we have less freedom. But in the case of primary schools, teacher education, and higher education, we have more freedom to advance with experimentation. And if you want to have a look, I have also some books about, for example, adventures in the world of matrices. There's an introduction to matrix theory, but starting with mat weaving in one part of the country in Mozambique. And step by step, matrix theory is built up, and even new matrices, new types of matrices, not known before 2002, which have been discovered in research in Mozambique, are introduced, and they have interesting, also visual properties. And that's maybe one remark I could make. In the history of South Africa, in the history of Africa, mathematics is closely related to geometry and to art and design. And that should be explored also in one way or another in the curricula. Mathematics is not only applied to the natural sciences, not only applied, like I said, the example to linguistics, but in particularly also in the history of Africa, the relationship between mathematical ideas, development of mathematical ideas, design, and art. And I think it will be very interesting also at the level of universities to try to make links between these areas and see how to explore that, also in order to develop not only mathematics, but also design and art in our part of Africa.
Thank you, Professor Gerdes. Will you join me in thanking him for his fantastic talk? Thank you.